Good morning. So today we start the lesson. This is actually the most important part of this chapter. It's a very important theorem in differentiation that's called the chain rule. You will see why people call it the chain rule when I start teaching that. But let me try to motivate you because this is an extremely important lesson. So if you do not learn this lesson, then you will be in trouble for the rest of this course. So you need, probably we will not be able to finish it today, but we start very important parts today. So first, let me just motivate you. For example, so if I give you this function, h of x, for example, x to power 5, and I ask you to differentiate it, it's extremely simple. So you get 5x to the power of 4. But let me change the problem a little bit. So I give you hx to be equal to x squared plus 1 to power 2. Okay, and then I ask you to calculate the derivative of h again. Okay, so if you want to use the same rule that I use for this simple function, meaning that I bring 2 down, and so for example, I bring 2 down and write x squared plus 1. So I mean, I'm trying to find an analogy between the previous formula that we had, x to power c derivative is cx to power c minus 1. Of course, I am allowed to use this formula for this case, because if you compare the function that I have with this function, you see they are exactly the same, and it is clear that here 5 is playing the role of c. But if you compare this one with that formula, they are not exactly the same. So you cannot say that this is also definitely following the same rule, giving the role of c to 2 and giving the role of x to the whole x squared plus 1. This is what I want you to understand. In general, there is no guarantee that we can do that. If we could, then of course the answer would be this. But you will see that the answer is not this. And by the way, this is not above your knowledge. This is a math 3C problem. If I give you this and I ask you to find the derivative, how should I do it properly? Yes, Casimir? Yeah, we just square it. So this is the correct way of doing it. X to the power of 4, 2 times the first one times the second one, and the second one to power 2. Then, of course, you know how to differentiate it. So then it becomes 4x cubed, and then I have plus 4x. And you already see that this answer is not correct. Because if I multiply 2 in, it becomes 2x squared plus 2, which is not this function. You cannot doubt about this method because that's completely plausible. I just expand that, so this function is exactly the same function as here, and then I am using 3 rules, yes? I have the sum of 3 functions, so I can use the addition rule. I have a number multiplied by function, so I can use that rule as well, and I can, for this one and for this one, I can use this formula. And then for the constant function, I know that the derivative is 0. So this is, we cannot doubt about this result, that is correct. But then you see that this is not exactly equal to this. Okay, so, but you might say that, okay, for differentiating this, I could do it, but let me change the function a little bit. So for example, let me just give you this function, x squared plus 1 to power 200 rather than 2. Still, the problem technically, I mean theoretically, you don't need a new math knowledge to solve that. But technically and practically, it is extremely hard. Because if you want to do the same thing here, you have to expand this and multiply it by itself 200 times. Then, of course, you get a very, very huge polynomial, but theoretically, it is not hard. It is extremely tedious to do that. Okay, so what we are supposed to do then, either we have to give up to find the derivative of this function, or we have to find a more efficient way. And the answer is that yes, we are going to find a better way to do it, and that is the content of the chain rule. So the chain rule is a very important theorem that helps us to actually differentiate this function and functions similar to that. But what is actually important in the chain rule is the idea of composition of functions. So this is the terminology we use, even though might be in English language composition and combinations are more or less the same thing, but I want you to use the composition word here. So I want to talk a little bit about composition of functions. Okay, so what do I mean by composing two functions? So first of all, this picture of a function as an operator is extremely important to have to adopt from now on. So when I write a function f of x is equal to x squared, I want you to realize this x is just a representative. Using that, I am telling you what the input is, and I am giving the role. I am just telling you how f operates. So how f operates, whenever I provide an input for this f, it will take the input from me, square it, and give it back to me. So the best idea to visualize that is that f is a machine that takes from you an input. In this particular case, what it actually spits out is the square of the input. So this is the way that you have to visualize a function. Okay? So for example, if I decide to send A to this machine, f, what do you expect to get back?
A squared.
A squared. So this is, I want you to understand, if I send, I don't know, for example, b to the power of 2 minus 3c, what do I get back in return? I get this quantity, which plays the role of my input, squared. Yes? So this is what I want you to visualize when we talk about functions. B squared minus 3c to the power of 2. Okay, so let me, for example, change it slightly. So let's assume that I have another function and I decide to send g of x into this machine, yes? So what the answer is? If you ask me what g of x is, I don't know. G of x is another function. I'm sending it to f. Yes?
G of x squared.
Yeah, it becomes g of x squared. So don't doubt about this, yes? This is g of x squared. So is that clear? So in principle, if you want to visualize a function is f, you send x in, the output is called or denoted f of x. Even though sometimes I'm also using this sloppy language and say that the function f of x is equal to x squared, technically speaking, it is not correct. Because f is the machine itself, okay? F of x is the product of the machine, is the outcome of the machine. For example, I don't know if you have a meat grinder, you put meat in it, that is the input. What you get is the grinded meat, but you cannot say that the grinded meat and the meat grinders are the same. Meat grinder is the function. The output is f of x. So this is the way to visualize every possible function. So you see that there is not a big role to the name that I use for my input. I can change the name of x to y to whatever I want, the role of the function. If I want to say this in English, I would say this f is a squaring function. So whatever I provide for it, it squares it and gives it back to me. So that's the way that you understand. Okay. Now let me just give you two functions, and then I want to get close to the idea of composition of two functions. So let us, for example, take a function g of x, for example, to be x squared plus 1, and let me give you another function f of x, x to power 200. Okay, so how do you visualize this function? This function is a machine g. I send x to it, it gives x squared plus 1 back to me. And x is just a name for the input. Okay, so here, what is f? So let me just write f as a circle. I send x here, and then what do I get? I get the input to power 200 back. So this is how you visualize these functions. But let us apply these functions on one particular input consecutively. For example, f after g. So what do? I apply first f, I apply first g. It means that I send an input x to g. What do I get in return is x squared plus 1. Then I take the product of this first machine and send it to the other machine. Okay, so I will send this one to the machine f. What do I get at the end? What do I get? This is playing the role of the input of this machine, and this machine takes an input from you, raises it to power 200, gives it back to me. I am sending this to this machine, so the machine will do the same thing for this. So it will take the input, raise it to power 200, and gives it back to you. So what happens if you call this part a new machine and do not look inside? So what's happening? X is going in, x squared plus 1 to the power of 200 is coming out. Yes? So this machine is exactly this machine, which is h. Yes? So I can, if you do not look inside, I can call it h. So this is called composition of functions. So h of x is this, this function. It is a composition of two simpler functions. One function is a squaring plus 1 function. Another function is a function raises to power 200. If you compose these two functions, the output is what you want. The chain rule is a theorem, extremely important theorem, that tells you if you know how to differentiate these two functions, I will give you a way to differentiate the compositions of two functions. So that is the content of the chain rule. Is that clear? Okay, and then by the way, be careful. These operations are not commutative in general. Okay, so it is important to keep the order, because which one is operating first? G. Which one is operating later is f. Here I apply g first and then f. Okay, so the answer is exactly the function that I want. Okay, by the way, there is a mathematical notation which is missing in the book, but if you want to write this, you say this is f o g. It's a little bit a strange way of writing, because this probably you will think that f is acting first. No, this is acting f. This is called f after g. Okay, f after g is exactly what you see here. But this notation is not in your book, so you don't need to be worried about that. Okay, but just let me tell you what happens if I change the order. For example, instead of sending x first to machine g, I send it to f. So let us see what happens. So I send x to f. What is the output here? What is the output? X to power 200. But then I will take this and send it to g. So what will be the output here now? What is that? Yes? Exactly, because this is the rule of this one. So this becomes x to power. This will go to this machine, will play the role of the input of this machine. This machine takes the input, square it, plus add 1 to it, and give it back to me. So this becomes x to the power of 200 to the power of 2 plus 1. Yes? So of course we can write this a little bit simpler, which becomes x to power 400 plus 1. And I hope that you appreciate that x to the power of 400 plus 1 is completely different from x to the power of 2 plus 1 to power 200. So you see that this black box, if you want to call it something, it is not the same as h. So I can, for example, give it a different name. Let me call it S. So is that clear? That's the idea of a composition of functions. So, but the idea is to be able to understand this on your own, and you really don't need to write any details here. So whenever I give you this function, you need to understand that is a composition of two functions. Okay, and that is not hard. If I give you x and I ask you to calculate this, assume that you have a calculator in your hand and you are supposed to calculate this. So what do you calculate first? You calculate x squared plus 1 first, and when you get the answer, you use your calculator and raise that answer to power 200. So which function is acting first? It is easy to see that you are facing two functions. One function, which is acting first, is x squared plus 1, and then the function which is raised to power 200 comes later. But these two functions composed in this order will give rise to the function that I am interested in. And the content of the chain rule, I haven't talked about that yet, but this will be a very important theorem that helps me to calculate the derivative of a function which is a composition of two or more than two functions. Is that clear? So that's the idea behind this. Okay. Let me do some practice here first. I want to see that if you understand how to do it. For example, if I write this function, let me write it h of x, and let me write this function, the square root of x squared plus 2x negative 1. Okay, can you tell me how many functions are involved here? Keep it as simple as possible, okay? I mean, give me two functions that if one is acting and then the next comes and act, and then you will get this function. Yes? So, for example, the one that is acting first, let us be clear. I will call my function h for the time being. The function that acts first, I want to call it g, and the function that comes later, I will call it f for the time being. Exactly, I want to follow the book. Okay, so can you tell me what is the first function acting for h? Yes, what is that? Yes, you wanted to say something?
No, I don't have an answer.
Yes?
So, well, first function could be x squared plus 2x minus 1.
Yes, exactly. Because if I give you a calculator and I give you x, if you want to calculate this combination, you do not start with pressing the square root. First, you calculate what? X squared plus 2x minus 1. And when you get the answer, you start applying another function to the result. Okay, this is important. I want to make sure that you understand this. Can you tell me what is the function involved after this is done?
Square root of x.
Yes, square root of x. That's it. Yes, is that understandable? So you first take this function, calculate it, you get the result, you put the output of that in this function, you get the result for h. So the book is using this idea that this is called the inner function. I'm just using the words in the book, inner function. The function which is acting first in your book is called the inner function. And the other one, of course, is called the outer function. Okay, well, that's correct. But let us, by the way, make sure that everyone understands that, not in graphical form, in mathematical analytic form. So you need to calculate this. You need to calculate g first and then f. Yes? So I apply g on x. Whatever I get, I apply f onto the result. So let us see how it goes. So which one is acting first? G. So this means that I am not allowed to touch this for the time being. I need to calculate g of x. But I already know what g of x is. G of x is x squared plus 2x minus 1. Yes? And now, what is f of x squared plus 2x minus 1? What is that? F is this machine, takes you an input x, takes an input from you x, gives you an output, the square root of that input. Now the input is this one, so it will give this to you. Yes? And what is this? That is exactly the function that I started with. I don't need to that you write this in the exam. This is not part of the solution. The point is that I am trying to improve your skills to understanding how to decompose your function to simpler functions. So is that clear? So we introduce these two functions, and f of g of x is actually h of x. Okay, let me write another function here. So this function, let me call it h of x. Let me make it a little bit more complicated this time. Okay, so let me write e, the Euler number, raised to power square root of x to the power of 2 minus 3x. So how many functions are involved here? So if you don't mind, let me call this one, let's call it h. So how many functions are involved to be composed to give rise to h of x here? Okay, so if I give you the calculator and I give you the x, which part of this you start calculating first? Yes? No, which one? Yes, x squared minus 3x is the first one you do it. Okay, so let me call that g of x again. Yes. Okay, after this calculation is finished, you give the result of this calculation to another function. What that function is, so let me call it f of x. What is that? Square root of x. But it is not finished, because so far you calculated this part. But then you want to calculate h, so there is another function involved. I already reserved letter h here, so let me call it s of x. So what is s of x? E to the power of x. So the composition of these three functions is this function. Now, if I ask you, do you know the derivative of g? You would say yes. Do you know the derivative of f? Yes. Do you know the derivative of s? Yes. Then later I will teach you, by knowing the derivative of these functions, how you can use the chain rule to find the derivative of that function. I haven't talked about that part yet, but I'm just trying to make it clear for you. So if you want to write h in this language, so you say that h is first g of x, after that f, after that s. So h is s after f after g. Yes, is that clear? Okay, good. Now let me write the formula here. Today I will not teach you why this formula is correct. The rigorous proof of that is a little bit hard, but I can motivate you why the formula is correct. But I'm not motivating you today. I'm just writing the formula and I'm teaching you how to use the formula. So the chain rule is this. The chain rule tells you that if you have a function coming after g, and then I give you, and I ask you to find the derivative of this. How do you calculate this? This is the answer. This is the chain rule. So the chain rule tells you that this is equal to, you calculate the derivative of the outer function, you calculate the derivative of the inner function, okay? But there is some technicalities going on you have to be careful about. So the inner function, you calculate the derivative g prime of x, but when you want to calculate the derivative of the other function, you do not write f prime of x. You calculate the derivative of f at the inner function. So this is the chain rule. This is the formula in the chain rule. This formula is also, of course, given to you in the formula sheet, but I really want you to memorize that to learn how to use it at least. Yes?
How does it look when there's three functions?
Now I will come to that. Okay, but let us, for example, ask you to calculate the derivative of this function. So let me write this example. Let h of x be equal to square root of x squared plus 2x minus 1. Determine h prime of x. So still we want to differentiate a function, but this is not what we could do in any circumstances using Math 3C knowledge. This is not possible. But here, I want you to understand, when you see this function, you have to improve your skills so that you immediately realize that function is a composition of two functions. Yes? So, because I have explained everything here, so let me just copy and paste those information. So this is the first thing that comes to your mind, that g of x is x squared plus 2x minus 1, and then f of x is square root of x. Okay? And this formula, either you have it in your memory or if you have it in front of you, what it needs the derivative of the inner function, which is this one, and it's extremely simple, no problems. So you just calculate g prime of x. What's the answer? It's 2x plus 2. Okay? So this part is actually extremely simple. This part is also simple, but you need to pay attention to it, okay? So when I say f prime g of x, of course f prime is involved. So I have to differentiate this. So this, I hope that you remember. I told you several times, it is extremely important to have this in your memory. What was the derivative? Otherwise, you have to start from scratch and calculating all the time. So do you remember what was the square root of x derivative? 1 over 2 square root of x. So I want you to remember that. But this is not exactly f prime of g of x. Let me go back to this diagram pictures, okay? So what is the meaning of this? This means that you need to visualize it in this way. I have a machine F. I send x to this machine. It gives this square root of x back. But the derivative is the derivative function. You derive it from the original function. So this is still a new function, So let me change the symbol I'm using for it. Its derivative. What f prime is acting according to its own rule. When I send x to f prime, what do I get back in return? 1 over 2 square root of x. This is the way that you need to think about function and its derivative. The process of going from here to here is called differentiation. But still, when you find the derivative is a new function. Okay? So, if I ask you, if I send 2 to this machine, I get the square root of 2 back. If I send 2 to this machine, I get 1 over 2 square root of 2 back. Yes? So here, the point is that you are not sending x to this new machine. You are sending g of x to this new machine. So that is the only thing that you have to do. So from here, you have to carry on a little bit. So f prime of g of x you need to calculate. So this means that instead of sending x to this machine, you are sending g of x to the same machine. So what do you get in return? 1 over 2 square root of g of x, yes? So let me just write it first. These are all details. I will tell you how to do it fast later, but uh, essentially you have to learn to do all these things faster. Okay, but I will tell you how to do it more efficiently. This is the case, but you can continue a little bit because you know what g of x is. What g of x is that guy. So this becomes 2 square root of x squared plus 2x minus 1. Yes? So what do I need? I need this term, which I have it now. I also have this. I need this. I have it. And then according to the here, h prime of x, which is, this is, if I say what this is, hopefully you understand this is exactly the same as h of x as I described here. So its derivative is equal to this multiplied by that. So this becomes 1 over 2 square root of x squared plus 2x minus 1, yes, multiplied by 2x plus 2. So that is your derivative. But of course, if you want, you can simplify a little bit. Here you can factor a 2 out, and that 2 that I pull out will cancel this 2, so you can write it a little bit nicer. So h prime of x becomes x plus 1 in the numerator divided by x squared plus 2x minus 1. So if you understood what is going on, so you really understood what is the how to use the chain rule. But there are some questions left. Why do you think that this formula is the correct formula? And the other thing, as Gustav asked, what happens like here if I have more than two functions composed? But the answers are easy. So the first question probably we will address it a little bit later. Today I just want to concentrate on how to use the chain rule formula. Now I want to I think might be it is a good idea to solve one more problem. Then we will come back to a situation like this that we have more than two functions involved. So let us keep everything here and then do another exercise. Okay, so for example, let us consider the starter for today. Yes, what was that function? So the function is this. H of x is equal to x squared plus 1 to the power of 200. Okay, so then we want to find h prime of x. Do you remember the naive way of doing it was to bring 200 down and then write x squared plus 1 to the power of 199. Of course, we don't have any reason to believe this is true. We are just trying to use the analogy here. The analogy, you will see, it will not work. Okay, and then this will be wrong. But let's see how wrong it is. Okay, so here h prime of x we want to calculate. So how do you calculate it? How do you analyze the problem? Hopefully you immediately realize that it's also a composition of two simpler functions. So what is the inner function here? So you call it g of x. What is the inner function? Which one acts first?
X squared plus 1.
X squared plus 1 acts first. This is the inner function. And then what is the other function?
X to the power of 200.
X to the power of 200 as described later. And you know that the formula is in front of you up there. So you want to use the chain rule. Do you agree with me that if f acts after g, I will get this? This you need to convince yourself. You don't need to really write that in the exam, but you need to know, you need to distinguish or recognize these functions correctly and convince yourself that yes, if g acts first and then f comes after that, I will get the same function that I want to find its derivative. Okay, so everything is okay. You know what you need. You need g prime according to the chain rule formula. So it's extremely simple to calculate. It becomes 2x. You need f prime, but not f prime of x. So let us calculate f prime first, which becomes 200 x to power 199. Yes, that is clear. But I do not need exactly f prime of x, I need f prime of g of x. So I hope that you understand what is going on. So can you tell me what will be f prime of g of x? This is also a machine. It takes x from you, raise it to power 199, multiplied by 200. You have the same machine involved, but this time you are sending g of x into it. So what is the answer? It becomes 200 g of x to power 199.
Yes.
But we do not write g of x because we already know what g of x is. So I continue a little bit more. So this becomes 200 x squared plus 1 to the power of 199. So I have everything that I need. I needed g of g prime of x, I have it. I needed f prime of g of x, I have it. So the final answer is h prime of x is just the product of these two results. Yes, I would write that one, 200 x squared plus 1 to the power of 199, which is exactly this naive guess, but it is not complete because you have to multiply it by an extra factor here, which is 2x. So this is the only difference that matters here in this case. Okay, so then if you want to simplify that, it becomes h prime of x is 400. I prefer to write x on the left, and then I would write the same thing here. This is the derivative of this function. Yes, please.
Why is it not the same as just doing it regularly?
No, this
Mathematically, it's not the same, but why?
okay. So if you want to see why, first of all, uh, why it should be, because the formula we got was for this.
Yeah.
Okay. So yeah, this is the formula we got. So it means that we found the derivative of this very particular function in which c is any constant that you like, but the base is just x.
But what if you change the x squared plus 1 to an auxiliary variable?
Yes, I understand what it is. So that's a very good question, by the way. So what he is saying is that, okay, if this is working for this, so that's the exact point. That's the idea of the chain rule. For example, if I want to answer this, I can just tell you that this is the case. Okay, so for example, let me make this simple. Okay, so let me make this one 2, and then this becomes what? 2, and this becomes 1. This is one of the cases. Okay, how did I get this? Do you remember? I wrote that the limit of f of x plus h, which is x plus h to power 2, minus x squared divided by h goes to 0. This is how, if I continue this limit, at the end I will get 2x. Okay? But now let us, for example, change x to x squared. Okay? So what happens here? So you are thinking that if I change x to x squared here, using that auxiliary variable that you are saying, then I will get 2x squared here. Okay? And of course, first of all, you know that this is not correct, because this becomes x to 4. You know the answer is 4x to the power of 3. But your question is deeper than that. Your question is that why we should expect this, because if you give me this When I want to calculate that, I will not write this, you know. So let me see. This is x to the power of 4. If I want to start from scratch, I will write the limit x plus h to power 4 minus x to power 4 divided by h. H goes to 0. Do you agree? I have to calculate this. But this limit is not that limit if I replace x with x squared. If in this limit I change x to x squared, I will face a new limit. X squared plus h squared minus x squared to power 2, which is x to the power of 4 divided by h. H goes to 0. And this, you see that they are not the same. Is that clear? So if I want to calculate this limit, this is correct. But you see that if I replace x with x squared, if it is possible to replace this x with a squared, this means that when I change this x to x squared, the limit should be equal to this limit. Is that understandable? But they are not the same. So you see, when I change x to x squared, I get this limit. When I start from x to the power of 4 in the beginning, I will get this limit. Of course, these terms are exactly the same. Yes, that's okay. H's are also the same, but this is x plus h to power 4. This is x squared plus h to power 2. And there is no guarantee they are the same. Yes, if they are always the same, then you are right. You can use the idea of auxiliary variable. Yes? So that's what I'm saying. But that is a very good and deep question. You might say that why can't I use the idea of auxiliary variable here? I can consider that x is the input. Now I am changing the input to x squared. No, the answer to this is, if you want to do this, you need to see that what happens from scratch. This is doing things from scratch shows you that in this case it is not possible. Yes? Okay. Anyway, now let us go to this question. How do you want to calculate this derivative of such a function which is a composition with 4 more than functions? So let us answer this question theoretically first. Okay, so what do I mean by theoretically? So I will start from here. I don't care about what S, F, and G are. I just say that S after F, F after G. Yes? 1, 2, 3, 1, 2, 3. Yes. I want to, and then another one for the derivative. So we want to know what the formula for this is. So what should I do? You can read this. That was only for 2 functions composed. Then I want to understand this one. So what you can do, you can just now give the auxiliary name to this. So for example, let me call it, I don't know, capital G. Or if you want, I can change the name completely. Let me write it as t of x. Okay, so how many functions now become involved? 2. One s, t, s after t. Okay, so can you tell me, can I use the original version of the chain rule here?
Yes.
Yes, because I have composition of two functions, s after t. Okay, can you just tell me how should I write this? So I have a product here. On the right hand side of the product, what I'm supposed to write? T prime of x, the derivative of the inner function. Yes? And what should I write here?
S prime of dx.
S prime calculated at t of x. So that is exactly the same chain rule. But here it needs another chain rule. Yes, because t itself is also a composition of 2 functions, f after g. Okay, so this means that I cannot do anything with that. It's not needed to do anything with that. I just copy and paste. And then, can you tell me what should I write instead of this one now? Imagine in your head, t itself is f after g. So what should I write here? Don't look at here. So this is the chain rule again. So I have a product here. What can I write on the right hand side of this product? This is your t. T is f after g.
F prime of g of x.
No, here on the right hand side.
Oh, g of x.
G prime of x. So here I have to write g prime of x. But what should I write here? F prime of g of x. That's it. So you start actually differentiation in order. S prime, F prime, G prime. Exactly in the order that they appear. But the only thing is that when you calculate S prime, you have to calculate it at T of x. What was T of x? Let me clean it now. What was T of x?
F of g of x.
F of g of x. And then you go to the next one, F prime. But you do not calculate it at x, you calculate it at g of x. And then you go to g prime, and then you calculate it at x. So that is the version of the chain rule for three functions. Let us make sure that you really understand what's going on. Let me, by the way, if you want to prove it, how to prove it for, so let me just write for the four functions. Okay, so how can I write it for four functions? So let me just write some functions. F after G, after H, after say S. And then I put X here. 1, 2, 3, 4 brackets open. 1, 2, 3, 4 brackets closed. And then I ask you find the derivative of that. So can you tell me what should I do? Hopefully you understand the pattern. So F prime is involved. Then G prime is involved. Then H prime is involved. And finally, S prime is involved, yes? But I want your help to fill up these gaps. What should I write here?
X of x.
Only X. What should I write here?
S of x.
S of X. What should I write here?
H of s of x.
H of S of X. And finally, what should I write here? G of H of S of X. So that is the version for four functions. Okay? And then you can continue. But if you want to prove it, can you tell me how should I prove it in general for n functions? Mathematical induction. Yes. So if you want to prove that for n is an integer, is a natural number, so you can use mathematical induction. Okay, so if you don't mind, let us now go back. This is a problem. It's very similar. I think in the book they have written x squared plus 1. I have written x squared minus 3x. So let us solve that problem together. Okay, so here, I will write it here again. So let me raise the board a little bit. So h of x is equal to what? E to the power square root of x squared minus 3x. Okay, and I am asking you to calculate the derivative of this. The first thing comes to your mind, you have to analyze the problem yourself by you understand this problem is a composition of three functions. That is the first thing that you need to know. Okay, but you have already done that, so if you don't mind, let me just copy and paste those. So the innermost function is x squared minus 3x. The middle function is a squaring function, square root of x, and finally the outermost function, h of x. Oh, let me call it s of x here, as exactly as here, e to power x. And then you have this formula in front of you. Of course, I want you to understand the formula, be able to find it from your memory again. But anyway, by looking at this combination SFG, you need S prime, you need F prime, you need G prime. So without further ado, so let us just calculate these things that I need. So G prime of x is extremely simple. It becomes 2x minus 3. And then F prime is also hopefully simple for you. You have it in your memory. And I don't know, do you have this one also in your memory or not? This was a very famous function. It's probably a very nice function because its derivative is equal to itself. It's e to power x. Yes? But the point is that, let us look at this formula. I need g prime x exactly as I have it. Good. But f prime, I need to do some minor changes here. Because here I have f prime of x, but I want to have f prime of g of x. Okay, tell me what to do. So this means that f prime of g of x is equal to what? 1 over 2 square root of, instead of the input x, I have the input g of x, so g of x will sit here. But what is g of x? Don't spend so much time to write g of x and then replace it. Okay, g of x is this one. So this becomes x squared minus 3x. And then for this one, what do I need? This is important to understand. So what I need here is s prime of what? Of f of g of x. Because this is what I need. Okay, but can you tell me what is f of g of x? If I compose only these two functions, can you tell me immediately what do I get? I get what? F after g only, up to this point. It is what?
Is it square root of
Square root of x squared minus 3x. Exactly, thank you. And so this is what I have to put here. But what is s prime of x? S prime of x is this guy. When I say s prime calculated at this, it means that I need to replace the x in s prime with this combination. But that combination is this. So finally, it means I replace x in s prime with that. Yes? So the answer becomes e to power square root of x squared minus 3x. And then according to this modified version of the chain rule, you have to multiply all these three. So then finally your answer h prime of x is this term e to power square root of x squared minus 3x multiplied by 1 over 2 square root of x squared minus 3x multiplied by the whole 2x minus 3. Simplification is usually not necessary because I want to emphasize only on taking the derivative correctly. So you see, this is a little bit innocent function, but derivative becomes a little bit complicated. Yes.
So on an exam, it would be okay to answer
Yes,
like
I
this.
will explicitly mention because simplification is needed or not.
Okay, but if you don't mention
Yeah,
it,
you don't,
then
yeah,
we
yeah,
can ask like
yeah.
that. Okay.
But I mean that you see, it's more, so it might be the function e itself is extremely simple function because its derivative is equal to itself. But if you start tampering a little bit with the exponent, then the function still, that's essence you see here. This function still repeats itself as the original function e to power x repeats itself. But this is not the whole story anymore. You have more terms involved. Yes? So that is the essence of the chain rule. And the reason it's called the chain rule, I think you now understand why. Because these differentiations are coming like loops of a chain. Whenever you think it's finished, another loop comes in. When you think this is finished, another loop comes in. But that's good that the number of loops are finite. Otherwise, you have to wait for the loops to finish. Okay? So that is why it's a good name. It's called the chain rule. So is that clear? Okay, so when the lesson ends, do you know? Because I still want to continue. So we continue. Okay, so we have enough time. Okay, but this is, by the way, you see, this is your understanding. First, I wanted to improve your understanding about what is going on in the book and everything. But then I want to do it faster. Yes, because it's extremely boring if you want to write all these unnecessarily things to be able to find the answer. Okay, but I want you to understand that I am not doing something new. I want to do the same thing in a more efficient way. Okay, so let me just try to teach you that part, and then that would be the end of today's lesson. Okay, so what I want you to understand is that always you will be given a table in the formula sheet, in the formula sheet. So here, this is more or less a simplified version of that you will get. So you will get something like this in the exam, that if it's a constant, it is 0, for example, I don't know, x to power c is cx to power c minus 1. So I told you that this package you will not get. I really want you to memorize that, otherwise you have to calculate all of them from scratch every time. So if you have x, this is 1. If you have square root of x, it is 1 over 2 square root of x. And if you have, I don't know, 1 over x, it's just minus 1 over x squared. And then we had something other. So here in our list, we have e to power x, which is e to power x and things like that. But what I want you to understand, let me just rewrite the original form of that here. Yes? So what happens here? The original formula of the chain rule, which you will also get in the formula sheet, this is the original form. What I want you to do is just to do this. Give this g of x a name. So I would say let u be equal to g of x. Then the formula reads like this. F of u prime is equal to f prime of u multiplied by u prime. This is the way that you see it. Yes? So this is important. If I have just x here, there is no difference between saying f of x prime or f prime of x. They are the same. Because if x plays the role of u, then u prime becomes x prime, but x prime is 1, so this means that these two are equal. But if u is not the trivial case, is something more, for example, u itself is x squared, I don't know, u itself is another function of x, then this is the chain rule written in this new form. So this means that the difference between these two is only a multiplication by u prime. That's the only difference. So this is why I want you to tell this is the one that you take, you have it in exam. But you can generate whenever you need a new formula table for yourself like this. So let me write like this. Okay? So if I give you c, of course, this is against 0. But if instead of x you have u to power c, you follow exactly the same rule as before, as if u is x, so this becomes c, u to power c minus 1, but the only problem is that you shouldn't stop there because there is a multiplication by u prime going on. So you just multiply by u prime. Yes? For example, here, square root of u. If I ask you to differentiate the square root of u, you will follow the same rule as if you can pretend that u is x in your head. It becomes 1 over 2 square root of u. But the point is that for x, you stop there because x prime is 1. But here, you shouldn't stop here because there is no guarantee that u prime is also 1. You just multiply by extra u prime. So that's extremely simple. This table, you will not get it in the formula sheet. You will only get these formulas. But you need to understand you can set up a new table for yourself. I would call it the chain rule version of the table. And it is not hard to actually see what happens. You follow exactly the same rules for x. The only exception that you need to remember is that for all of them, you multiply by an extra factor of u prime every time. Okay? So you might say, what is the difference? That's the same story. Yes, I agree. That's the same story because I haven't invented that. I have to follow the rules. But the point is that this is much faster. For example, let us go back to that example here on the board. If I want to redo it again, I will never write these things. So what I do, I start immediately differentiation. So I would say that, okay, you tell me that h of x is the square root of x squared plus 2x minus 1. This is the question that I ask myself. Which part of it is good to call u? And how can I answer this question? That part of this function I call u. so that after the substitution is done, I get a formula in my table for it. For example, this is a good idea to take this u in my head. Because why? It becomes the square root of u. Do I know a square root of x in my table? Yes. So that is a good substitution. And then I do it. H prime of x, what does it mean? It means that I follow exactly the same formula. I told you this you will not get. This is the only one you get, for example. And then the square root of x is 1 over 2 square root of, you can pretend that u is the same as x. So you write u here, but u has this name. So let me write this. In the case of x, this was the end of the story. In this new case, you need to remember, this is the only thing that you need to remember. You need to multiply by an extra factor of u prime. Yes? That's it. So if you give me this, I will never write all these things. I just start writing h prime is this one. And I continue until there is no prime left. So there is a one prime left. So I have to continue. And then I have to be a good copy machine because I have to copy and paste these parts. Yes. X squared plus 2x. And then you shouldn't be lazy for that. And then what do you do here? Take the derivative. It is just 2x plus 2. And if you compare, that's exactly the same answer we got. I want you to understand, because I could teach you right away this, but then you will not feel the connection between what I told you here. But then I also care about doing things efficiently, so that's the most efficient way to do it. Okay, now let us do this example using this trick, okay? This is important because I have seen some mistakes from student side. So here, you need to understand what to do. So let us keep the answer to this here. And let me solve it a different way. So h of x is e to power square root of x squared minus 3x. Okay, so what I do, I need to think which part is good to call u. Okay, I want to test your understanding, because if you make a mistake, then I will correct you. Hopefully you will learn what to do. Yes?
X squared minus 3x.
Yeah, this is the first impression. But this is not good. Why is that? Because if I take this to be u in my head, what do I generate? I generate e to which power? Square root of u. This is what I generate. But this is not good. Why? Because in my table that you will get in the formula sheet, you do not have the formula for e to power square root of x. You only have the e to power x. So this change of variable is not a good idea. Just please concentrate, because this is very important. Did you understand what I said? So this is up to you to decide which one to take u. There is nothing wrong with taking this u unless you don't know what to do. You should take this one. Do I have it in my formula sheet? If the formula sheet is generous enough to include that formula here, yes, I would say this is good. But the formula sheet is not that generous, so you have to be able to use it. So this is not a good choice. Okay, so then what is the alternative? Yes?
The square root.
Take the whole square root of x squared minus 3x to be u. Yes? Why this is good? Let us check. If I take this u in my head, so what will happen? I will face e to power u. But now you see e to power u is essentially here, because u and x are just names. Okay? Okay, so what you I will take this one to be u. Okay, tell me what to do. H prime of x, you don't need to write it down, by the way. This is in your head. E to power u. You want to differentiate it. You go to the line in your table which says something about e to power x. The derivative of e to power x, according to the table, is e to power x. So the derivative of e to power u will be the same, e to power u, but you shouldn't stop here. What do you need to do? You need to multiply by u prime. And then don't get you used to writing this and cleaning them and just substitute them. You can just do it in your head. This is your u. Yes? Is that right? This is the first step. Is it clear for everyone?
Yes.
But is it finished? No. Why? Because there is a prime left. So it means that you forget about everything else in the problem. Just assume that this function is given to you. So it means I copy and paste the parts that I don't need and then just concentrate on calculating this. Let me just repeat everything again. Can I do this directly? No, because in the table, I have a square root of x, not a square root of x squared minus 3x. So this means that I have to use the chain rule once more. So it means that I have to give the role of u to something here. But what is that something here? Yes?
X squared minus 3.
This time x squared minus 3, which was not good from the beginning, but this is the only option here. So in my head, I take this one to be my u. The new u, if you want to. Is it good? Yes, because it generates a square root of u. The square root of u is comparable to the square root of x. Okay, so I take the derivative. What is the derivative? It becomes 1 over 2 square root of u, but u is this guy, so x squared minus 3x. Is it finished?
Yes.
No. Every time you have to multiply by u prime. So what is u prime? Is x squared minus 3x prime. Is the problem finished? No, because there is a prime still left. So that you feed, that's called the chain rule y. Yes, because one after the other it's coming. And then I told you, be a good copy machine. So just you have to copy this. Yes, x squared minus 3x. But for the last one, it's a math 3C problem. What's the answer? It's 2x minus 3. And this is the answer I get. This is the answer we got in the previous one, which is the same. But this method is what I want you to learn. Do not describe these things. Of course, if someone asks you why this is correct, you should be able to say that, okay, what I am doing is exactly following the chain rule because of this, blah, blah, blah. But this is the most efficient way to calculate the derivative of this function. Any questions? So this lesson is extremely important because if you do not learn this lesson, then you will have problems with the all coming lessons, even the next chapters. Okay, so this is extremely important. So might be 1 or 2 sessions I will continue practicing about this. But I think it's good to stop here. Any questions? Okay, thank you.